So also a very warm welcome for me. My name is Ahem Stirner and I'm invite you to our today's webinars showing you some examples of use from the practice. And let's start. So we want to show you some examples how our customers use our tools to produce more economically and more flexible their switch cabinets. We want to explain you this in our schematic. We can see here, we'll go in our circle to the process steps and explain you the solutions of our customers. A special thanks to those customers who allowed us to show some photos and some videos in our today's webinar. These are real practical examples from those customers. There are much more customers using our tools, but those have provided us the video and photo material for today. Thank you. So let's start with the mechanical processes. In this case, we do not have own machines within our partnership of the 4 partners, but we provide the data for those machines. There are neutral format with DXF exported from the E3 cutout tool. So if you have a digital twin in your E3 series, you can export all the necessary information for drilling, milling, and producing cabinets and mounting plates, as well as supporting the data for cutting machines for terminal rails and for cable ducts. The neutral format has the advantage that it works very for all common machines, but a special version is all for the Perforex. There is also a special format available who is directly optimized for this machine. So this is also available. And there are much more solutions done in the market, done by the customer itself. So these are standard tools, but it is possible to do to program your own tools. Okay, next. So then we have some applications for the component marking and the placement. So also here is a standard tool available called E3 ET Print to export labeling information also in a neutral format. Important is that nobody has to write the data from the schematic in an Excel file by manually process, so that all the data are exported in a very comfortable way with filters and sorting and much more. And then you can put this to your printer type. That can be a normal regular laser printer, or as shown here in this picture, the very high-end rail laser machine. But important is always to get the data from the system, from E3 series, in a very comfortable way to the machine without any data loss. And this is possible by our export tools who are available since many years. Okay, then I will hand over to Christian showing some more examples from the rail laser.
Yes, thanks, Achim, for the introduction, and also from my side, a warm welcome to today's webinar, where we want to have a look inside real life and real use of our machines. And the first example which I brought with me is in the area of automatic assembly and marking with the rail assembler and the rail laser. So there I want to bring or present to you the example of the German cabinet builder BAH Industrial Solution. So it's a medium-sized company, totally 120 employees, and BHA Industrial Solution is handling different areas. So for sure, they are building cabinets, they have also an area of quality control and testing, industrial assembly, as well as engineering and service for data centers. And this customer provides solutions for cabinet building from planning to final assembly. And during the last years, this company has grown strongly, especially in the area of cabinet building. I think a lot of you are familiar with the growing rates during the last years. And that's the reason why they start to build a new production hall. And they moved into this hall in summer this year. And their claim and their target is that they want to be control cabinet, or that they want to provide control cabinet construction of the latest generation, even faster, even more reliable, and even more individual. And that was a task where we had several discussions and analyzed that for them, the setup of having a rail assembler and a rail laser is really something that helped them in the field of digitalization and automation of their electrical control cabinet construction. Why they choose the rail assembler and rail laser, which features were very important for them. First of all, the seamless connection of planning and production data. So as Achim already summarized, for sure at the beginning they generated digital twin. They are using an ECAD system going then to the Weitmüller configurator and then directly on the machines. So they really have there the seamless connection. Second point is the easy handling of the machines. Some of you might know already our rail laser from other webinars. So just as a short reminder, if you are using the rail laser, you just have to put inside the pre-assembled DIN rail, fix it, and press the start button. So it's really very simple to use this kind of the machine. Then the topic of universality is very important for them. We see it on the right-hand side of the slide that also one aspect of their claim is even more individual. So they have to handle several components. And for example, at the rail assembler, we achieved this point by having their universal component magazines, so they can put different kind of components on the same magazines. They don't have to buy any other magazines. Or at the rail laser, we achieved this point by being able to handle not only terminal blocks, the machine can also mark on other DIN rail components with nearly the same size. For sure, another point is time savings. We are talking about up to 90% time savings for the rail laser, and they have in the end a consistently high quality level. So if you have there 20 or 30 DIN rails, same configuration, same marking, then they really look same. And for sure, for them, it was also very important that, especially for the rail assembler, we have there a longer period of unmanned operation, so they can fill up the magazines in the morning, and the rest of the day, the machine can run without any manual interaction. In the end, from their point of view, they use already state-of-the-art manufacturing technologies. They have innovative processes and experienced, well-established team. Based on that, they are well known for the field of control cabinet construction. And with the rail assembler and rail laser, we secure this position also for the future. So I think this example is very useful for you, because there you can see they build up a new production hall. During this building process of the production hall, they restructured a lot of their processes. And there, I think it's one of the best situations to really go one step further, and including there also fully automated solutions to be really well prepared also for the future. So that was just one example for the fully automated assembly and marking. And based on that, We will come back a little bit more in the area of assisted workplaces, and I will hand over again to Achim Stirner.
Thank you, Christian. So from the high-end rail assembler to a small tool, but maybe it can also help. A lot of suppliers have modular components who are like these connectors. They have maybe up to 20 different parts, and our tool, the assembling cockpit, is a way to show these pre-assembly in a smooth way, so that you can see which parts do you need and where do they have to be placed. So this is very easy for small pre-assemblies. It's only a software solution or inside of your E3 series, but maybe it helps you or in your production. The other way is the export to the rail laser via the white model configurator Christian shows, and also there are some various report templates existing helping to doing the pre-assembly. So the next slide, what we can see is a step in between the fully automated solutions is that some of the customer have their normal regular cabinet production, but then they add these digital tools instead of their paper. So they put a monitor and a software next to the workplace to have the helping how to wire and how to place, and maybe in the next step how to check the wires, and this is all supported with tools and instead of paper. So this is maybe a step in between to the next assisted solution, and like we can see here on the bottom picture, the system from ELAM, from Armbruster Engineering. Timo will show you. This is a high-end solution, but important is that also it is possible to export the necessary data for those tools directly from E3. So there is no manually work to create those data for the machine. This is all available by existing export interfaces. And with this, I want to hand over to Timo, showing the next step of assisted cabinet assembly.
Thank you, Achim, and welcome from my side. My name is Timo Tessin. I'm from Armbruster Engineering, and I will show you something about the assisted assembly for cabinet building. In preparation for the cabinet assembly, you need to equip and install different components. The most important topics are here: the component identification. So am I using the correct components? The work instruction. Am I assembling in the right way and the right position? The monitoring of screwing processes and component picking. That means, are the processes being carried out correctly? The component labeling for the verification in the final assembly. And lastly, the photo documentation to document the finishing products. Next is the component identification. The component identification is for order picking or assembly. This means documentation of serialized components, also for proving parts against bill of material. Because parts are so different, glove scanners or handhelds are sometimes used in this case. The next is the digital work instructions. The work instructions have to be integrated into the customer-specific environment, as we can see here on the different pictures. We have a variety of different options for presentation. This can be stationary or as well a mobile display, like we can see in the lower left picture on a tablet. This gives us fast onboarding, time saving, and error reduction in the cabinet assembly. A special part of the work instruction is the work instruction projected. Projection of component position, work instruction, and extra information. For instance, pictures of the assembly, short video clips of the part assembly, and measurements, for example, for configuration of special components. This also gives you time saving and error reduction in the cabinet assembly. Next is the monitoring of screwing process. For monitoring the screwing processes, we are integrating electronic screwdrivers. With this, we can record and document the torque, angle, and the tightening programs. With all this information, we can evaluate the screwing processes in the Elom web server, and this also gives us a high error reduction possibility. And lastly, the monitoring of the component picking. Also for order picking or assembly. Here, the system displays the picking directly at the component storage location. The picking will be documented in the system and also can make direct replenishment orders via the module. This results in faster onboarding, time saving, and error reduction as well. And I will give it to Tilman for the next.
Yes, hello. Here's Tilman Hotz from Komax. Komax is very well known for fully automatic wire processing in different sectors, mainly in automotive, but now over the last year, more and more also in the area of control cabinet manufacturing. And we will see here in our circle where we are now. So we are at the position where we do wire pre-manufacturing, so that we pre-manufacture the wire sets in a central cutting area, which then delivers all the wire bundles to the workplaces where the wiring is being executed then. So let's jump into this. And why is Komax now more and more active in the control cabinet manufacturing? This is due to the fact that the wire processing and wiring up a control cabinet is one of the areas where the biggest efficiency gains can be reached if this process is more digitized and more streamlined. Maybe you know this study from the University of Stuttgart that claims that there is a potential of saving 80% of the time during the wiring process. And so we wanted to see, is this true? So we went back to one of our customers where we have a long-time relationship, which is Liebherr. Liebherr is very well known for the cranes, but they do a lot of heavy equipment where they use a lot of switchgear and control cabinets to run those systems. And as mentioned, we have a long-time relationship to Liebherr. So Mr. Weizenegger from Liebherr, he gave us kind of a history, how it started and developed, and what benefits they can draw now from changing their ways of building a control cabinet. So Liebherr Components in Biberach is a company of 100 employees just in the control cabinet manufacturing, where they ship over 2,500 control cabinets per year. And they started an analysis in the early 2000s to see where is the potential to increase efficiency. And from those potentials, they started to realize them step by step. And the first step was to implement the Zuken E3 design software. And with this design data, already sending data to some components. The first use of data was the printers to print identification for components and connections. And the next step was then to send the data to the mechanical machining machines that do the cutouts in the metal frames of the control cabinets. And then in the 2006, they started to produce also the wire sets automatically, not fully automatic. In a way, they were producing on Komax machines that can run one wire and one terminal type. So they can produce same type of wire, same type of connector on this machine. But for a mixed wire set, they had to do changeovers. But even then, they had a very quick amortization, return on invest of this machine within 1.5 years. And then the next big step was in 2007, when they started to integrate all the component geometries in the Zuken E3 design software. So that's the point when they really went into 3D engineering. So they had all dimensions of the components, and with the components, they had also all information how this component has to be connected. So the information about connector type, is it a ring lock, is it a ferrule with 8 millimeter stripping length, whatever. So all information comes with a component and is in the design software. And also this design process, they started to modularize so that not all functions are designed from scratch, but they can really draw from a big library of functions that they then can combine to a new component. And today, if you go one slide further, they use such kind of 150% template, so where they have all functions they need in general, they have completely engineered, and with a CIM-based configurator, which is also from Zuken, they can then choose from those templates what they need and create a new drawing. But not only a new drawing, they can also extract and all the information for the printer, for the mechanical machining of the control cabinet, for the connection lists. So everything that the manufacturing needs will immediately be delivered because it has been once engineered, and now they can just draw the data by using the configurator. Now, if we go one step further, we see how they automated the mechanical machining, very straightforward, using equipment to cut wire ducts or terminal rails, and to do the cutouts in the metal frame of the control cabinet. And then in the next step, we see here now the modern manufacturing of Liebherr in Biberach. So we see a huge assembly hall, and on the bottom left, we see the central cutting area where all the wires are being prepared, which then are distributed in those gray boxes to the assembly area. And a big important step at Liebherr happened in 2018 when the so-called Liebherr Components branch was created. So it's a company within the company. So Liebherr Components provides all the control cabinets to all the other Liebherr product groups and subsidiaries. So this division is now a service provider within the company, and they have also to benchmark themselves against other control cabinet manufacturers. So they were really highly motivated to increase their efficiency and to become the supplier of choice within the Liebherr conglomerate, which they very well achieved. But to be very effective here, they had to be able to handle with a huge variety of different type of control cabinets, of different wires that are being used, of different connection types that are being used. So they needed a very flexible machine. And that was the moment when they invested into a Zeta machine. A Zeta machine, I hope, or I believe many people know it. So just a very quick look at it. You take the data from the digital twin, in this case from the Zuken E3 design software. This process, these cutting lists are sorted in a meaningful way, so you can produce bundles that belong to one area in the control cabinet or one component. On the machine, we have up to 36 different wires and different methods to treat the wire ends. And at the end, the wiring worker, he gets one bundle that belongs to one component in the control cabinet. And this bundle can consist of different wire types, different diameters, and different terminal types on this wire. So really, he doesn't need any manual wire processing anymore. And in this context, I want to stress out something that is specific about, in this case, Liebherr. They don't use the typical ferrules anymore. What they just need is a stiff wire end that they can use to push the connection into a typical push-in connector. And for this, they are using a module that does electrical welding on the wire end. That's one method that is very suitable for an automated machine, so that on different diameters and different stripping length, you can use just one module to do the wire end treatment. And there are different ways to do this. So on the left, we see, or we go one slide further where we see this also in motion. We see the typical ferrules, which we can use on the machine because we have on the Zeta machine a module that can process 5 different wire ends. But you're still limited because sometimes you need a different stripping length, or you have more different diameters that can be processed on this ferrule module. So a way to be more flexible would then be the next method. The next method is ultrasonic compacting. That's a module from Schunk that we integrate on our machines, where you can insert either a wire bundle, or in the control cabinet manufacturing, it would be one wire where the strands are being compacted by applying an ultrasonic vibration to the strands, and this forms then a very solid and stiff wire end that can be easily inserted into terminal blocks. So that's one way, and this is freely programmable in terms of diameter and length. Another method that we see on the next slide is then a compacting of the wire end by resistance welding. So by sending a strong current, very strong current peak through the wire end, and this then slightly melts the strands, and this results also in a very stiff wire end. This is very suitable for high volumes, and it is also freely programmable for all different wire diameters and stripping length. So we see that we have here 3 methods that are very suitable for fully automatic wire processing machines where you need a high flexibility. So here we have a quick summary of the findings of Mr. Weizenegger of Liebherr, how they could improve their efficiencies. So I think an important point is here that even for batch size 1, they see that this has become very efficient by organizing their data in a very good way, by working with templates and a configurator to be able to very quickly deliver the data to the machine in a meaningful way. So there's no intermediate manual interaction necessary. And by being so quick and being able to work on batch size 1, they could also reduce their stocking and their storage costs. So there's much less material in the whole process involved. It's really produced on time, and then the whole project can be shipped very quickly. If we jump a little bit to the bottom of the slide, I mean, at the bottom line, we see the summary that Liebherr was able to reduce their time effort they spend on the 1.2 million connections they do per year by a factor of 3. So there's a big time saving, and there's a big saving in lead time in their manufacturing. And I think what we can take away here also from the experience from Liebherr is really that during the whole process, all the divisions had to be involved. So the engineering, the production, and the IT, they work very closely together. And I think that's something that everybody really has to take away. It's very important to consider all the divisions in your manufacturing to make this really a success. Okay, so far, I think a very nice experience story from Liebherr Components. They implemented really the data flow very seamlessly from one production step to the next, and they can now really benefit from this effort that they have done over the last years. With this, I would give back to the next process steps in our circle.
Yes, Tilman, thank you very much for showing us a world of fully automated wire processing. You very well explained how the bigger cabinet builders can make use of the technology, and especially also for the different technologies for the treatment of the end of a wire. For sure, also for some smaller cabinet builders, there are solutions available, for example, like our wire processing center. And there I want to explain to you the story of our customer BN Automation. So it's a customer who is in various industry sectors active, for example, water treatment, energy, or even industry, providing their solutions for automation, data solutions, software, electrical engineering, information technology, so a huge basket. The company was established in the year 1990. Medium-sized public limited company, roughly 2,400 projects conducted on a global level during the last years. And their target in the field of wire processing was to have their bundling up, increasing in-house competence for the field of wire processing, establishing efficient processes in their own production, enabling workers to focus on value-adding activities. So they also had there the discussion which operations or which work steps should be conducted by which operator, handling a complexity of various conductor color combinations, and handling this information also on a central data platform, where, for example, this customer is also using our wire processing center tool. So it's a special kind of a tool to bring the information out of the ECAD system directly to our machine. And for them, it was important to find their balancing between investment and the best possible flexibility level. For sure, also the monitoring of project progress for planning expert is very important for them. And that's the reason why they choose in the end the wire processing center, because there we have the software guided cable confectioning. We have there implemented a one-piece flow concept. So you imported the data, and then first the cutting unit is knowing how long the cable has to be cutted. The crimping unit is knowing which end wire treatment is required, and the printer is printing the right information at the same time. But they want to also have the flexibility and efficient usage. And for example, with the wire processing center, you can use this as a one-piece flow, and you can use all of the machines as well as or in standalone mode. For example, if you just need 50 cables, length 1 meter, both sides and end ferrule, you can just directly go to the machine without any interface and press the button and start with the operation. Process safety is ensured by the interaction of all the systems by a central software unit, and for sure the data consistency and ease of handling is also ensured based on this solution. So also another example, different challenges at a different customer and different solution to fulfill these different challenges. In the end, to make a long story short, the feedback from the customer was flexibility is a top priority for them. They need to be able to assemble wires and cables and cross sections in a short time and between projects. And this is the reason why they choose the wire processing center to really implement all these required technical features in their own production. So another example that we from Smart Cabinet Building are really willing to support you with a full basket of different kind of solutions. And based on that, we will come to the next process steps, where Achim will show you again some of the solutions for the field of wiring, testing, commissioning, and even service.
Yes, welcome back for some tools helping you in the process of wiring and testing. So please, next slide. Thank you. So there's one software tool. We saw now the hardware tools from the Comax machine on the wiring processing center. There's one software tool called E3 Wiring Cockpit, who can help you increasing your efficiency in wiring a cabinet. So the basic idea was to help the worker doing the wiring directly from the roll. So he has here the necessary information, the length of the wire, and also the treatment of the ends, and the source and the destination, and the length and color and so on, and the way how to do it. So this also works of course in combination with pre-produced wires from the WPC or from the Comax machine, and this helps you the worker to get to do step by step one wire after the other, and you can do this on a tablet, so you don't need any paper or something else, and it is always documented which wires are done and which the worker has to be done. Another impression here is from Stadler. They do a digital way of the testing and the commissioning of their whole trains and the cabinets of the train. On the left side, you can see the formerly way. Typically, there is a printout of the schematic, and then the worker always highlight or mark the wires he has checked, but this is still paper, and normally the problem is this paper is normally often not up to date. So it is better to do this in a digital way. You can do it on a tablet or on a laptop, and you can also mark all your tools, all your connections you have done. So if you go to the next slide, please, in a comfortable way, and also you can add some notes if something is wrong from the wiring or for the devices, that maybe there is the wrong device maintained or something else. So you can give this information directly back maybe to the development department, so that they have to use maybe another part, or if there was an error in the production, then that they know, and they always can in the second iterative circle doing just all the errors, checking if they are corrected in a different way. So all digital to reduce the paper and be up to date with the protocol and logging, and so this is a up-to-date tool how to test and check your system, your cabinet. There are some other tools also existing from created by our customer himself, but this is our standard tool, the wiring checks, and is well used, example, especially here at Stadler Rail. Okay, then next slide. So there was a lot of tools and a lot of examples. If you have further question, I think there was one question in the chat. Maybe turn the answer at the next. If not, then maybe if you. Oh, Tilman, do you want to answer the question?
Yeah, I saw the answer and want to. Yeah, I want to answer, but I think unfortunately I deleted it. So the question was, what kind of wire end processing Liebherr was using And the answer is the main process that Liebherr is using is the resistance welding. So to compact the strands with a high power electrical current that you send through the wire ends.
Okay, so if you have further questions you don't want to ask with our chat, you can contact us directly. You can see here the email and the telephone numbers. So if you have further questions, don't hesitate to contact us. And then the next slide, I want to invite you to our next webinars. Normally it's always on the last Wednesday of the month. So today we are out of our series because last week was the fair, the SPS Connect, and so we moved our date to today. And the next one we put it on 16th of December because of Christmas. But in the next year, in January, February, and March, you can see there are some more interesting topics we want to provide you in our webinar series. We hope that you will join us. So at this moment, I want to thank you for your attention from Suken, and I think my colleagues want to do this as well.
Yes, we also like to thank you for your attention, for your time, for your interest in several topics. So as Achim already mentioned, if any further question will arise later, feel free to contact us directly. Otherwise, we wish you a good pre-Christmas time, and for sure, take care and healthy Christmas.